Hi, and welcome to the Calculus 3 assignment practice series. And we are practicing some problems from the unit vector calculus. Excuse me. This is our assignment number 7 about the curl and the divergences here. So let's take a look and let's try to do some of the problems in this section to get familiar with the curl and divergence the definitions and applications here. Okay, so let's go to our worksheets here. Okay, so for these worksheets here, so the first 3 problems, find the curl and the divergence of the vector field. So these 3 problems are quite mechanical. Basically, you just plug it into the formulas and that's it. Okay, so I think everybody should be able to do that. So I want to take a look, is more like a concept type of the problems here. So in the problem 9, 10, 11 here, we have 3 vector fields, right, in the XY plane. And so in here, let's say that means the same in all the other horizontal plane. That means we really treat this F, right? It's like it's Z components, it's 0, that's it. So we want to see the divergence of the F is positive, negative, or 0. And then we want to decide curl F equal to the 0 vector or not. If not, then which direction the curls point to. Okay. So I'm going to do this. First, let's do just by eyeball the graph and then kind of make decisions about it, okay? Then we're going to do a little bit more, like we say, hey, the mathematically, you know, we can kind of show how to mathematically agree with your eyeball. Okay, so like in here for the 9, you see your vector field is going this way, right? So going up. Obviously, it does not have what? It obviously does not have any rotation movement here, right? So if you move the points, it's going up. So I'm kind of expect the curl F will be equal to a 0 vectors here. That means it's no movement. And then also then from the divergence points, right? So if you move in here, right? So if you move in this directions here, then it's kind of like the, instead of divergence, it's kind of like more convergence here. That means you get the points more and more. So if you think about it, this is water molecules, right? So you kind of go into these directions here. So you accumulate more and more. So it is not divergence here, right? So that means if it's not divergence, I expect the divergence F here should be a negative value here. All right. Okay. So now this is our eyeball intuitive feeling about this field. So let's take a look. How can we prove this one here? Okay. So now in here, because we know now this field is in R2, so the R is equal to what? I is equal to 0, right? And also because this vectors here is all, this vector field is all go up in the y direction. So I know my P x y z is also equal to 0, correct? Okay. And then I know the rho P, rho X, okay. And so now, because that's what we have here, all right? And also let's take a look at another ones here. You see this vector field, right? So when you go increase in the y, what happens here? The magnitude is getting what? Smaller and smaller, right? So it's kind of like you see the Q is what? Is decreasing, right? It's decreasing as what? As y increase. Great, right? So that means if I do rho Q, rho Y, going to be what? Is going to be less than 0, right? Because the Q decrease and then the Y increases here. Okay, and so now because okay, So because also we see another ones here, we know the Q does not change over. So it's just go up and down, right? So it does not change over X or Z directions, right? So what's that mean? So that means I know the rho Q, no, I mean that means because it's, okay, so that means the rho Q to the rho X will be equal to rho Q to what? Rho Q to the rho Z, right? So the rho Z equal to zeros here. Okay, so now let's take a look at the divergences here. So the divergence based on the formulas here, we have rho P, rho X plus rho Q, rho Y plus rho Z, rho R, I should say rho R. Okay, so this is rho R and rho Z's here, right? Okay, so now we know rho P and Z are both equal to 0. So this is 0 and this is 0. And also we just discussed, we said rho Q over rho Y, that means the Q value when you increase the Y is less than 0. So what is here? So this is what? So this is negative, so the diversion is negative. So it's not a diversion, it's in fact, it's a convergence here, right? Okay, so now let's take a look at the curl F here. The curl F, if you plug into our formula, is rho R, rho Y, minus rho Q, rho Z. And this is my I direction, plus rho P, rho Z, and minus rho R, rho X. This is my J directions, all right? And plus rho Q, rho X, and minus rho P, rho Y here, right? So rho P, rho Y here. And so this is the K directions, right? So this is the curls here. Okay, so let's take a look here, right? So this one's here, let's see here. So this one is equal to 0. Q, rho Q, rho Z, right? Rho Q, rho Z, this is equal to 0. Rho P, rho Z, P is equal to 0. So this is rho equal to 0. Rho R, rho X, this is equal to 0. And the rho Q, rho Y is here, right? So the rho Q, rho Y, so the, okay, so now I'm sorry, this is rho Q, rho X here, right? So rho Q, rho X, right? So rho Q, rho X, and rho P, rho Y, and all this, so this will be equal to 0, this is equal to 0, right? So I know that this one's here, the curl F is equal to what is a 0 vector. So that is why it is not, you know, it is not kind of there's no rotations, you know, the motions there, all right? Okay. Okay, now let's take a look at the next ones here. The next ones here, first also, let's just take a look. You know, if by, you know, if just take a look here, right? So in here, you know, if I just eyeball in here, we said, well, I did not really see any rotation movement. So I would expect the curl F is equal to a 0 vector. And also in here, you see the, excuse me. So you see the flow. So like, then you will see here, right? So like, you know, you start to carry out. So they do kind of what? They do kind of the, you know, like the thinning out, right? So I expect this is a divergence because they kind of the, so if you have a lot of the water molecule here, so when the field go like this way, and then the molecule gradually going to thin out. So we think this is possible, it's divergent. That means that the div of the F has to be positive here. Okay, so now let's take a look at this ones here. So this is our eyeball data, right? So this is eyeball data is what is our conclusions here. So now let's take a look at mathematically to see if they agree with us or not, okay? So the R, since R is equal to 0, this is in R2, right? So the R, so PQR, so then the rho R, rho X, going to be rho R, rho Y, going to be rho R, rho what? Rho Z, all equal to 0 because R equal to 0. Okay, so because of both of the P and the Q does not, right? So does not vary in the R directions, right? Because we don't have R directions here, right? So that's why I know what? I know the rho P, rho Z is going to equal to the rho Q, rho Z. Both is equal to 0 because they only vary in the X, Y's here. Okay, now let's see here. Let's take a look at the P's here, right? The P components here, the PXYZ here, right? So let's take a look at this ones here. So the P is the X components, I components, right? Okay, so let's take a look. So when the X increasing, so when the X increases here, so what happened to the X components here? So that means the X components increasing, right? So that's why I know what rho P, rho X is going to be what? Greater than 0. And then because here, but Y components, right? Y does not change. So Y is the same height, like you see here. This is X, this is X, this is X, this is X. So X increase, but Y remain the same here, right? For each one here. So now I know for the Y components, right? So when X increase, right? So the same thing when the X increase here. So what happened to the Y components here? Has not in change. So rho P rho Y equal to 0. Okay. So now let me take a look at the, for the Q part, right? So Q part. So when the Y increase, see what happens here. Okay, so in here, when the Y increase, okay, so Y increases here. What happened to the X components here? X components is not moving, right? X components not moving. So that means rho Q, rho X is not moving. So it's equal to 0. And the Y components here. So when Y increase, so you see here when Y increase, oh, the Y start to getting bigger also, right? So that's why I know the rho Q, rho Y is what? Is have a greater than 0 here. All right. So now let's start to take a look here. So the divergence of the F is going to be rho P, rho X plus rho Q, rho Y plus rho R, rho Z here, right? Okay, so this one's rho R, rho Z, this is 0. Rho Q, rho Y, rho Q, rho Y here. This part is what is greater than 0, just like in here, right? Then the rho P, rho X, rho P, rho X is here. So it's also greater than 0. So the whole thing's divergent F is greater than 0. So we know this is a divergence here, correct? Okay, so now we can take a look at the curls here, right? So basically, okay, so for the curls here, right? So you can just plug into the formulas here. So what is the formulas here? We have rho R, rho Y minus rho Q, rho Z, This is I, then plus rho P, rho Z, minus rho R, rho X. This is J, then plus rho Q, rho X. Right, so plus rho Q, rho X, minus rho P, what? Rho P, rho Y to the K, right? Okay, so let's see here. All right, so I guess rho R, rho Y, this is 0. Everything related to the R, this is 0s, right? Then the rho Q, this is X here. Rho Q, rho X, right? Rho Q, rho X is equal to what? This is equal to 0. And rho P, rho Y, this is equal to 0. Rho P, rho Z, anything to the, see what we have here? We have a curl. F is equal to a 0 vector. So that's why we say this is not a rotation movement. So the same way you can show the number 11 to see what you can come out with the conclusions here, right? So this is a very interesting. Okay, so now let's take a look. All right, so let's take a look at number 12 here. So this is the concept type of the problem. So I think it's a pretty good problem. Okay, so the curl F, right? So they said, hey, to see first things, to see if it's meaningful or not. If it's not, explain why. And also you say this is vector field or scalar field. So we know that by the definitions here, the curl of the F here is what? This one here is what here? This is the vector field, right? The divergence here, okay, so the gradient of the F here, right? So the gradient of the F, that means is del F. So what here? This is a vector field also, correct? Right. Okay, so now divergent F. So what is here? We know the divergence is a constant. So this is a scalar. Curl for the gradients, right? So curl gradient. So this makes sense because gradient, this is a vector field. So what do we have here? So we have this is the what? We have this is the vector fields here. Oh, here, sorry, here. This one's here. We said that this, I thought this is big F. This is a small f. So the curl, right? So the curl has to go with the vector fields here. So this one's here. This one we say does not make sense, right? Okay, it's meaningless, right? So, okay, so gradient for the f's here. Okay, so the gradient need to be a scalar function. So this is meaningless, right? So how about the gradient to a diversion of the f? This is a scalar, then you take the gradient. So that's good. So this is what? This is a vector field. Okay, then let's take a look at the other one. It said the diversion of the gradient field. Can I have a diversion of gradient field? Yes. So what is turns out to be the scalar, right? So gradient of the divergence of f here. So can I have that? No, this is meaningless. Why is meaningless? Because the divergence here, this is the problem. Divergence, you have to be work on vector field. Okay, so the curl and the curl, can you do that? Oh yes, so this is still come to a vector fields, right? How about the divergence? So these ones here will become scalar. Now you cannot take the diversion with the scalar, right? So this is meaningless. Okay, gradient time cross product diversion. Gradient, this is vector. Vector cross the constant. Can we do that? No, right? So no, so this one is meaningless. Because this is the vector field, right? So this is a vector field, and this is the scalar. So when you use the cross product, it has to be the vector cross, the two vector fields here. Let's take a look, see here. This is a gradient. Then you take the curl with gradient, that's okay. And then you take it, so this is still is vectors, right? Vector field inside. And then can you take the diversion? Yes. So what is the final answers here? So it will be a scalars here, all right? So that is a pretty, so if you can understand all these problems here, so I think you have a pretty good understanding about your, the definition about all these different symbols here. Okay, let's take a look at one more. So in here, let's say, show any vector field of the form are differentiable functions in rotational. That means, what is that means here? That means you want to show this is a curl. F is what is zero, what is a zero vector. So if your PQR, so here is your PQR. If the P is only a function of X, the Q is only a function of Y, and R is only a function of the Z's here. So we can do just this is a curl F here, right? So remember the curl F, we do this matrix, right? So IJK, then you put it like a row, the operator. So row X, row Y, row Z. Then this is F of X, GY, and the HZs, right? Like we said, the way we do that, you can take the first two columns out. Then this is row, the row X, F of X. Then this is row, the row Y, GYs here, right? Okay, so now let's try to do here. This is what? So let's try to get different colors here. So this is the row Z, row Y for the I, and the J's here, we said this one's here is a plus, row F, row Z to the J, then plus here, how about this one's here, plus row G, row X to the K's here. And then minus, right? So minus this one's here. So minus row F, row Y to the K. And then minus the I, minus this one, minus row Y, row Z to the I. Then minus this one's, right? Okay, so the minus this one's here. So this is a minus what? Minus row H, row H, row Z, right? Row H, row Z. This is row H, no, row H, row H, row X here. Okay, so this is a row H, row X. So this is row H, row X. Here, I need to be careful. Here's another row Y, row Z. See, this is a row, but I need to put the functions there. So this is row GY. All right. Now here, the same way, I made a mistake here. So I cannot say row Z here. So what is here is row the what? HZs, right? So it's the H functions here. Okay, so that's why it should be row H. Okay, so this is a row H. Okay, as you can see for each terms here, for each term, this is 0 because H is only function of the Z, F function of the X, so this is 0, G is the function of the Y, so this is 0, F is a function of the X, so then you take the function derivative of Y, this is 0, G is a function of the Y, you take the Z, so it's 0, H here. So this is zeros, right? Okay, so what is your final answers here? The final answer will be a zero vector. So if it's a zero vector, that means F is irrotational. That means it's not turning in a circle, right? Okay, so then the next things here we talk about is incompressible. So when you see the word incompressible, that means there is no divergence, not diverging, and it's not a convergence here. So the indivisible, that means the diversion of the F is equal to what? Is equal to zeros, right? So we know the diversion of the F. So this is your P, this is your Q, this is your R. Okay, so let's take a look at diversion of the F is rho P, rho X. So that means you roll the F of YZ X plus rho Q. So it's rho the G XZ what? Rho Y. Then plus rho the H of XY to what? Rho Z here. So as you can see also, because this is a function of the f, y, and the z, you take the derivative of x, so this is 0. This is a function of x, z, you take the derivative of y, this is 0. This is xy, you take the derivative of the z, so this one is zeros, right? So the whole thing is equal to 0. That means the diversion is equal to 0. That means you are not diverging, you are not a convergent. So that's what we call this incompressible. Okay, that's it. So, you know, the concept of the curl and you know, the divergence is kind of a little bit hard at the beginning, but after you do the assignments here, I think you will get a pretty good ideas how that work and how do you look the graph and maybe get an intuitive feeling about it. All right. So that's it. That's it for the assignment number 7. I hope that the problem I did here can give you some idea and help you out to do the remaining problems here. All right. Okay, that's it. And have a nice day. And I guess I will talk to you in our next videos here. Okay, bye.